Okay, so today we'll just have, we could say, the history of electrochemistry and then basic review ng electrochemistry part ninyo at Gen Chem, and we could say analytical chemistry level. Because I think that's where it all started, the knowledge of what we called electroanalytical. So I don't know, hindi ko tanda kung may pH meter na ba tayo sa Gen Chem noon. But when you use a pH meter as early as Gen Chem, so that means you already have experience using electroanalytical method. So we will start from the time that electrochemistry was introduced and then just review. So baka sabihin nyo, masyado naman basic, but some said that when you're teaching, you're still not sure if what you're teaching is really the correct one. I'm just trying to find where is my, I know I already posted it. Electrochem, Chem 233, Electrochem, meeting 2. So let's look at how we could say electrochemistry started. So sa tingin nyo, ano yung first instances? Ano ba yan? That the concept of electrochemistry come in. So maybe it started way back. Ano ba yan? Pen. 640 to 546 BC. So it's just a long time ago when, I don't know how to pronounce it, Thales or Thales of Miletus is credited with the discovery that amber, when rubbed with cloth or fur, acquired the property of attracting light objects. Okay? And from this, they coined the term what? Electricity. Okay, it comes from the Greek word electron. So what do you think is the meaning of electron? So whatever material that you use it, so most likely, okay, you name it after it. Okay, so electron is the Greek word for amber. And then come years later, so there's a German guy by the name of Otto von Guericke. So he invented the first electrostatic generator. Okay, so this is how it looks like. Okay, so I don't know if you're familiar with the physics experiment, yung tumataas yung buhok nyo. Okay, or sometimes if you rub your hair, it interact with some other stuff because of the static that it is formed. Okay, so the first electrostatic generator is made up of sulfur, a sulfur ball, which rotated. Okay, so that's a sulfur ball, and it's rotated in a wooden cradle. Okay, so the ball itself was rubbed by hand, and the charged sulfur ball has to be transported to the place where the electric experiment was carried out. Okay, so you're going to look at this. This is how it looks like during that time. Okay, so eventually, the sulfur sphere was replaced by glass, and then later large discs were used to do that. And this is one of the anong tawag natin, equipment that they have put in the museum. Okay, how this electrostatic generator looks like. Okay, so you can still see them as of now. So it just trying to generate what we call static, electrostatic. Okay, and then in 1745, Ewald Jurgen von Kleist, okay, invented the so-called Leyden jar. So yan Leyden jar na yan, okay, it's used to store electric energy. Okay? So during that time, meron na silang concept yung tinatawag na electric energy. Okay. So this electric energy is usually this jar, they would contain either water or mercury. And it was placed on metal surface with ground connection. So I think if we're going to look at the history of electrochemistry, it's always related with what? A metal. Okay? Because if you put metal with one another, sometimes there's some reaction that you have there. Okay, so here they have water and what we call mercury. So if you place it into a metal surface, okay, with ground connection. So this Leyden jar, they were before he really invented von Kleist invented the Leyden jar. Okay, it was first done earlier in other what we call Leyden jar was invented by Mussenbrouwer and Kunus in the Netherlands. And the Leyden jars that they have there, they join it together to store large electrical charges. So the more Leyden jar that you have, the more electrical charges that you can have. But they said electrochemistry really start from an Italian guy. So credit they usually put to Alessandro Volta. The Count Alessandro Giuseppe Antonio Anastasio Volta. Okay, and this is due to this what we call the development of the first electric cell. And they call it the voltaic pile in 1800. Okay, so if you have a voltaic pile, usually it is consists of alternating layers. So if you could see here, of two dissimilar metals. So it's really the metals. Okay, and they separated by a cardboard soaked in sodium chloride solution or sulfuric acid. So what do you see here? A battery, right? So it's just, we could say, a crude version of the battery. And the way you differentiate them is you use different what we call metal, and then you soak it in a solution. So either NaCl or sulfuric acid. And Volta determined that the best combination of metal was zinc and silver. So this is an example of the what we call electric pile, and this is the one that you can see in the museum. Okay, and then other experiment that was done here. So what is Benjamin Franklin famous experiment? Anyone? You can say it. What's the connection of Benjamin Franklin in electricity? Anyone? You can type it or you can say. Ano yung famous experiment niya? Hindi nyo alam? Huh? I think I learned it from elementary. Okay, the kite experiment. Okay, so Benjamin Franklin demonstrated that lightning is what? A form of electricity. So the famous, we could say, kite experiment. So it's always, I don't know, I learn about it. I'm not sure if it's a grade 1 and grade 2. I just look like a photo of him with a kite and then a lightning strike. Okay. And then in 1780, another big guy. So usually the Italian are the big guy in electricity. You have Volta, where the voltaic cell is named after, and then the other Italian guy, Luigi Galvani. Okay, he discovered that muscles and nerve cells produce electricity. How did he discover it? What experiment is he doing? Usually, ginagawa natin to sa biology or we could say zoology. Okay? He's dissecting what? Anong hayop yung dinadissect niya? Okay? I don't know how's your experience in zoology. Meron kami mga palaka, tapos magtatalunan yun. Hahabulin sa lab. So what Luigi Galvani did is while dissecting frog on the table, where he had been conducting experiment with static electricity. So what Galvani did, he touched the exposed sciatic nerve with his scalpel, which he picked up to an electrical charge, and he noticed that the frog's leg jumped. So yung static galing doon sa scalpel niya, nag-cause ng movement doon sa leg ng frog. Okay? And then there are other, we could say, personality that's involved. Okay? So you have here English chemist and surgeon, Nicol Williamson, or William Nicholson, and the surgeon Anthony Carlyle. So they did the first what? The classic experiment, okay? Separating water into hydrogen and oxygen. I don't know if you heard a car being run by water. Narinig niyo na ba yun? Huh? And the question there, do you think it's real? Do you think it's possible? What do you think? I always ask my student like that. So maybe now I ask some students with higher learning. So what do you think? Is that possible? Because I always tell them it's not possible because of this. Because for the water to be split into hydrogen and oxygen, what? You need energy. Now for the what we call the thing to be true, so that means you're going to use water to produce energy. So this is really, we could say, very contradicting. But there's a big but. If you can invent the machine, okay, wherein you put water, and even though you use energy, but when they split to hydrogen and oxygen, they produce a much higher energy, then that is possible. That is usually what's happening in our body. So how do you think, I don't know if you learn it from Gen Chem, how do you think, okay, we produce large molecules? Ano ba yung entropy? If you're going to look at what we call the big molecules, what broken down to smaller molecules, and then how is it possible that the smaller molecules, okay, form into big molecules? How is it possible? Okay, so usually we have this so-called coupled reaction, right? Remember how ATP is produced? You still remember that? So usually you have a process from here going here. Okay? And usually you're going to use energy on that. But if you coupled it, okay, the energy that you produce is ATP, it can be used to drive a non-spontaneous reaction to be spontaneous. So yun yung concept na inaano doon. Okay, if you coupled your reaction with something, you can produce energy to make a non-spontaneous reaction to be spontaneous. But the thing is, the electrolysis was known since the 1800. Okay, and then this guy Johann Wilhelm Ritter, he discovered the process of electroplating. So electroplating, we could say, is another form of electrolysis. So he observed that the amount of metal deposited and the amount of oxygen produced during an electrolytic process depended on the distance between the electrode. Okay? But I think the other big guy that we have here is this one, Humphrey Davy. So he utilized the voltaic pile by Alessandro Volta in 1807, and he used the energy there to produce the potassium by electrolysis, and which was soon followed by sodium, barium, calcium, strontium, and magnesium. So the way that he do it is he had salt, and then he uses the energy from the voltaic pile to produce, okay, the form. And they said, okay, Humphrey Davy influenced Mary Shelley's novel, The Frankenstein. Okay, I hope you're familiar with Frankenstein, right? Originally, I thought it was based on what we called Luigi Galvani because of the frog, but I think Luigi Galvani has some papers about it, and Humphrey Davy, we could say, read about it. Okay, and then here he uses the energy to at least do this. What happened, I think, is the uncle of Mary Shelley is a friend of Humphrey Davy. But the big time person we could say in electrochemistry is Humphrey Davy's laboratory assistant. The name is Michael Faraday. Okay. Although before we go with Michael Faraday, there's another big guy that we have there is what we call John Frederick Daniel, where the Daniel cell is named after. So you could see all the cells that we have, galvanic cell, voltaic cell, Daniel cell, all of them came from people that we could say are pioneer in electrochemistry. So he's a professor of chemistry at King's College, and his research is into the development of constant current plays that took place at the same time that commercial telegraph systems began to appear. That's 1830s. So his copper battery became the standard for the British and the American telegraph system. Okay. And then in 1839, Daniel experimented on the fusion metals with a 70-cell battery, and he produced an electric arc so rich in UV that it resulted in an instant artificial, we could say, burn. And these experiments caused serious injury to his eyes as well as the eyes of the spectators. Okay. And the way the Daniel cell would look like, okay, like this one, and based on the experience that he showed that the ion of the metal, rather than the oxide, carries an electric charge when the metal salt solution is electrolyzed. So what you can find here is the ion, okay, either a positive or a negative. But if it's a metal, so it's a positive, okay? So that's the one that carry the electric charge. So this is how it looks like, okay? The early Daniel cell that you have. So it's almost like the voltaic cell, the galvanic cell, all the Daniel cell, okay? That we learned to know. And also during that time, Humphrey Davy's assistant, Michael Faraday, began his career, and he developed the two laws of electrochemistry. So the first law that he has here, the amount of a substance deposited on each electrode of an electrolytic cell is directly proportional to the amount of electricity passing through the cell. So this is the concept of what? Electrolysis, okay? Okay, and the second law of electrochemistry, the quantities of different elements deposited by a given amount of electricity are in the ratio of their chemical equivalence weight. So this has become, we could say, the basis on electricity, okay? So this is the one that is responsible. And if you go further, they have what we call the current war, okay? So who are involved in the current war? Usually it's Edison versus Tesla. So they have the AC versus the DC thing. And in the end, the more popular and the more, we could say, shrewd, Edison won in the what we call the current war. Okay? Now, Faraday is, we could say, able to define a number of terms. The anode, so this is based on some of the what we call writing. The anode is therefore that surface at which the electric current, according to our present expression, enters. It is the negative extremity of the decomposing body, is where oxygen, chlorine, acids are evolved, and is against or opposite the positive electrode. And then the cathode is that surface at which the current leaves the decomposing body and is positive extremity. The combustible bodies, metals, alkalis, and bases are evolved, and it is in contact with the negative electrode. Okay, so many bodies are decomposed directly by the electric current and their elements being set free. This I propose to call as the electrolytes. So he's the one who proposed this name that we know at present in electrochemistry. Finally, I require a term to express those bodies which can pass through the electrodes, or as they are usually called, the poles. They call it the poles, the two electrodes that they have. Okay, substances are frequently spoken of as being electronegative or electropositive. Okay, and according as they go under the supposed influence of a direct attraction to the positive or the negative poles. I propose to distinguish such body by calling those anions, which go to the anode of the decomposing body, and those passing to the cathode, cations. And when I have occasion to speak of these together, I shall call them ions. Okay, so I don't know if you know it, but the term anode, cathode, and ions, cations, ions, they are proposed by Michael Faraday. And he said the chloride of the lead is an electrolyte, and when electrolyzed, evolves the two ions, chlorine and lead, the former being an anion and the latter a cation. Okay, so they said without Faraday, we might not have the electricity as we know it at this time. So that's some they said that's he's the father of electrochemistry. Okay, and I included here, I don't know if you know Nernst, aside from the equation named after him, but he had what we call great contribution also in electrochemistry. So Walter Hermann Nernst. So what he did is study in electrochemistry were inspired by Arrhenius' dissociation theory of ions in solution. I'm not sure if you're familiar with Isbante Arrhenius. What is related to Arrhenius? Anyone? So this is just reviewing your Gen Chem. Who is Arrhenius? Okay. He's one who defined the acid base. The first one to define what is an acid and what is a base. And I don't know if you know it, but that definition of his acid and base, that's part of his dissertation. Okay. And his committee doesn't understand what he's talking about, so they just give him a passing grade. And then we could say 20 years after, he got the Nobel Prize for his definition of the acids and bases. So you will see, you think you're not what we call, you don't do anything great, but after several years and recognizing his contribution about acids and bases, so he got the Nobel Prize, I think, if I'm not mistaken, 1906. Okay, for his contribution about acids that form, if I'm not mistaken, H3O plus ion, and base that form hydroxide. And since they are what? Ions, so Nernst studied them. Okay, study their electrochemistry, how these ions, what's the ions electrochemistry in solution. And in 1889, he elucidated the theory of galvanic cell by assuming an electrolytic pressure for dissolution, which forces ions from electrodes into solution, and which was opposed to the osmotic pressure of the dissolved ions. Okay, and in 1889, he also showed how the characteristic of the current produced could be used to calculate the free energy change in the chemical reaction producing current. And this has become known as the basis of what? Nernst equation. And we will talk about that one. Nernst equation applied when there's a difference in the concentration, when the concentration is not equal to 1 molar. Okay? And independently of Thomson, so this is the J.J. Thomson fame, he explained why compounds ionize easily in water. And the explanation called the Nernst-Thomson rule holds that it is difficult for charged ions to attract each other through insulating water molecules, so they dissociate. Okay, I didn't include the current wire here, but okay, they are part because that's almost going to what we call electricity. Okay, the Tesla and Thomas Alva Edison. Okay, so this is how it all started. And if you're going to read some of the books, the materials in the books I gave you, they always have this Nernst equation, how it is related to most of the principle that we can see in what we call electrochemistry or the electroanalytical technique that we have. Okay, and later on, I'm going to post articles about the history of electroanalytical chemistry. Okay, but the electroanalytical chemistry, we could say, is much later after the electrochemistry has been established. Okay, so if we're going to talk about electrochemistry, we're talking only of this what we call redox reaction, the electrochemical processes. So there are, we could say, two electrochemical processes, and usually they are a reverse of one another. Okay, one that produce energy by a spontaneous reaction, okay, and the other that use energy to cause a non-spontaneous reaction to occur. So usually I always simplify it, produce versus the one that use. Okay, so this is the, we could say, the spontaneous one, that's the galvanic cell, the voltaic cell, or the Daniell cell as we know it. While this one, that is what? What cell do you call that? The electrolytic. And if you're going to generalize there, what is the term for the two cells? Anyone? What do you call them in general?
Electrochemical cell.
That's an electrochemical cell. Okay? And I don't know if you're going to believe me, I would say electrochemistry is one of chemistry's greatest contribution to mankind. I think all of us has an electrochemical device with us, especially if you have your phone with you. Okay? So usually, what do we expect in a redox reaction? Redox reaction in two words, what it is. Don't tell me oxidation reduction, because you're just like my undergrad students here. So what's the other term of a redox reaction? Anyone? Two words. Two words. And all my undergrad, reduction, oxidation. Okay.
Electron transfer.
Okay. Usually it's electron transfer or electron exchange. So one lost electron, the other one gained electron. So maybe you're still familiar with this one, right? Here in the Philippines, we call in the US we call it oil rig. Oxidation is loss, reduction is gain. But I always use the term Leora Geroa for them. And usually I don't know. This is tackled in the two general chemistry courses, the Gen Chem 1, okay, where it was introduced as a type of reaction, and then Gen Chem 2, where we have this topic on electrochemistry. Okay. Now, how do you know that there's a redox reaction? Anyone? How do you know that there's a redox reaction? Okay. So you have to look at the oxidation number. So there is a change in the oxidation number. So for instance, here in this reaction, so to determine if there's a redox reaction, you have to know the what we call oxidation number rules. Okay. So you still remember those rules on the oxidation number before we go back there? So usually when we're talking about oxidation number, this is the number or the charge of the atom that would have in a molecule or ionic compound if electrons were completely transferred. So ano yung first rule? Oxidation number is equals to 0 when? What do you have? Ano yung term natin? Elemental state or pre-element. So if you have the metal sodium, you have what we call lead, okay, you have oxygen, you have sulfur, all of them has an oxidation number of 0. Okay? And then the second rule is if you have what? Ions. Monatomic ions. So usually, the oxidation number is equals to?
Charge.
The charge. Okay? So it's really what we call basic, but at least it's going to reinforce your ground your foundation on this thing. Okay? Number 3, when we're talking about oxygen, usually, what's the oxidation number of the ionic oxygen, of the oxygen ion? Is equals to, not plus, -2. But if it's a peroxide, what's the charge that you have there? It's -1. Okay? So maybe easy lang tayo at this time because this is just, we could say, review, basic review. And then if you have what? Hydrogen. So usually, the charged hydrogen, it has +1. Okay? And if you have the hydride, that is equals to, oh, not -2, -1, like this one. That's a calcium hydride. So the charge of your hydrogen there is what we call 2. And if ever you have the so-called polyatomic ions or a compound, okay, the charge that you have is just equals to the sum of all oxidation number. So I think everyone will be able to answer this question. Okay, and if we go back here, we can assign the oxidation number here. So this is what? 0, 0, +2, -2. And then we say magnesium. What happened to magnesium? So from 0, it goes to +2. So electron is what? Lost or gain? Okay. So electron was lost. So we could say we have oxidation. And then the other one from oxygen to O2 minus. So from 0 to -2, so the electron was gained. So you have reduction. So I think all of you, okay, knows this. This is really, we could say, Gen Chem level. But as I've told you, just to reinforce the thing. Now, one thing that you have here is, we could say, the balancing. So usually in the balancing, you can use the loss of, we could say, the change in oxidation number state method. But I usually at this level, okay, ask them to use the half reaction method. So for instance here, what if you're asked to do it in acidic solution, or we could say basic solution? So what's the rule that you have here? So you divide them. So one has this. So what is this? Reduction or oxidation? Okay, so this is the OHR. And the other one is the RHR. So what would be the product? So Cr2O7, so most likely you will have here a Cr3 plus. And they said balance the number of the element. So here they're the same. Here you have 2 here, you have 1 here, so you put 2. Okay, you have 7 oxygen. So what you do, okay, you don't have any oxygen, you add, what do you add? 7 water. Okay, and when you introduce the water there, you're going to add also hydrogen here. So the elements are balanced. So what you do, the next one that you need to balance is the charge. So since this is oxidation, you expect the electron to be on the product because the electron was lost. And since this is a reduction, you expect the electron to be the reactant. So here you have what? A +6. So you have here a -2 plus 14. So this is 12. So you add here, how many electrons? 6. And then what's the next thing that you're going to do? Make sure the number of lost electron and the number of gained electrons are the same. So you have 6 here, you have 1 here. So you multiply them. So this becomes 6. And it's now balanced. And then you just bring everything down. And I think you have a balanced equation already. Then you double check, right? Make sure all elements are the same on both sides. 6 here, 6 here, 2 chromium, 2 chromium, 7 here. Okay, 7 on this side, and then 14 here, 14 here. And then the next one is the charge. So 6 plus 2, 6 times 2, that's 12. Plus -2 plus +14. So that is equals to what? 24 positive. So you have here 18 plus 6. That is also 24. So that means they're balanced. And they are in acid solution because you have an acidic species here, or a species that is acid. Okay. Now, how do you make it basic? You add hydroxide. Okay, so when you add hydroxide here, this becomes what? Water. And since you add 14 on this side, you also need to add 14 on the other side. Okay, and since you have 14 water here, you have 7, so this cancel out, leaving you with 7 water. And then you check again, everything should be balanced. 6 here, 6, 2, 2, and then you have your 7 plus 7 of the oxygen, so you have 14 here. And then you have 7 times 2, you also have what we call 14 here. 7 times 2 is 14. Now, in terms of the charge, okay, so this is what? 6 times 2, that's 12, plus negative 2, so that's a 10. And here, no, this is not, okay, this is right. And here you have what? 6 times 3, that is equals to what? 18 plus 6, then minus 14. And that is equals to 10. 10. Okay? So as of now, I think everyone knows about this principle. Now, I have another one, but I think, well, I'm not going to do it. So I'll go straight ahead on the galvanic cell. So in some book, it's still as the voltaic cell. In some book, there's a Daniel cell. So as you could see, all of them are named after some of the pioneer, we could say, people in the field of electrochemistry. So if you have a galvanic cell, it has a spontaneous reaction. Okay? So you have here an electrode. So you call this what? An anode. An anode is where? What happened in the anode?
Oxidation.
Oxidation. And then the other electrode is where we could say reduction happened. So the way I simplify it, I go to the English alphabet. This is a vowel, and this is a consonant. A and O are both vowels. C and R are consonant. Okay? And electron would always travel alphabetically from A to C. And what is in between them? A B. So usually this is A, B, C.
Bridge.
B is the bridge, the salt bridge. Okay? So I don't know if you have imagined that thing, that the cell that you have is just ABC. Even if it's an electrolytic cell, it's always anode to cathode. The only difference in an electrolytic cell is you provide energy to it. But this one, you produce energy. And if you're going to let them go, what will happen? If you're going to let the reaction go, can it go forever? Can the reaction go forever? Yes or no?
No, sir.
The answer is no. What will happen? All of this metal here will dissolve because you're going to have what? Zinc 2 plus. And what will happen here? What will happen to this color? Will it darken or lighter? Ano mangyayari dun sa blue color? Magiging lighter blue or darker blue?
Later, sir.
It will become lighter because the copper 2 plus will become
Copper.
copper metal. And what will happen? You will have a shiny brown color there. Okay? So that's usually what happened in this what we call galvanic cell. So this is a spontaneous, we could say, redox reaction. So anode is where oxidation takes place, cathode is where reduction takes place, whether it is a galvanic cell or a voltaic cell. So if you're going to look at the reaction that is happening, so you could see here the metal being deteriorated. Okay, and here more metals are deposited. And if you're going to look at the net reaction, you just cancel the electron on both sides. Okay, and this is usually the concept of the battery as we know it. So if you have the classic copper zinc battery, okay, so what you do there is you measure the difference in the electrical potential between the anode and the cathode. The term that you can have there at the Gen Chem level, you have their voltage, electromotive force, or cell potential. It's just so odd, right? Because you're going to have a term like what? Voltammetry. And then you have also a method that's known as potentiometry. But the cell, the potential difference that you have is can either be cell voltage and cell potential. So you might say, why? But you know that this one is going to be different with this one. But at this level, you see, oh, bakit ganon? And then all of a sudden, they went to separate ways. Okay? That's why I'm trying to discuss to you the basic one. Maybe it reinforce you, help you to teach the topic in a much, we could say, clearer way, or you can get, hopefully, new perspective on how this is being taught. And this is one of my favorite topics because a lot of students don't understand it. So the challenge is there for the students to understand this topic, especially when we go later on. Okay? When they try to calculate the cell potential, doon yung nakakalito. So far, so good. May natutunan bang bago or luma na to? Okay? So whenever you have what we call the battery here, usually the standard condition that you have is 1 molar. And you can have a shortcut for that, the cell diagram. And I say, you also write it in terms of what? A, B, C. So this is the anode. And you write it based on the reaction. Your zinc solid becoming zinc ion. And the bar line that you have there denotes difference in the states. Now, if you have a double bar line there, or vertical line, that is, we could say, a bridge, a salt bridge. So this is how you write it into what we call a shortcut of this galvanic cell. Okay? And you may ask, so how do we know that anode is the one that oxidized while copper is the one that is reduced? Okay? So usually, in knowing it, that means you need to study where you compare these metals and the respective electrolyte with a so-called standard. And that standard is coming in the form of what? The AHE, the standard hydrogen electrode. Okay? And the way that they put here what we call the standard hydrogen electrode, so they have there a hydrogen gas, okay, in a platinum wire. And what you have there is, this is really what? H plus. And the reaction that they have is this one. And what did they do? They assign it as a potential equals to 0. Why 0? Haven't you wonder if you're teaching this thing, the students ask you, why 0? Why not 1? Anyone? I think when I was a Gen Chem instructor there, I also don't have an answer for that. Why 0? Yes, Carmel.
Sir, I'm not sure, pero para yung mag-a-appear po na reading is automatic para doon sa counterpart na electrode.
Para a quadratic part. But specifically, why 0? Okay? So maybe, yeah, that's why I told you, during my time when I was your age, hindi ko rin alam. But with experience, why is it 0? Okay? You're using it as a reference. So if you're going to have it as 0, if the metal is stronger or weaker of you, when you reverse the reaction, the potential is still 0. So what is just telling you, if the reaction is reversed, so that metal might be stronger than the other metal if you reverse the reaction. Okay? So, isi-set mo siya ang 0 to the point that depending on the metal, it can be the 1, like this one. This is what? Reduction, right? So, kapag yung metal mas strong sa'yo, hindi reduction ang mangyayari dito. Ang mangyayari is yung fourth one. So, siya yung mag-oxidize. So, it's a very, we could say, simple convention that they thought about. Okay? So, when they pair it with the zinc, they generated this value. Okay? And from this, okay, they end up with this what we call relationship, that the self potential is equals to the self potential of the cathode minus the anode. So between here, what information do you know? So based on this, okay, you know that the value of this is what? 0.76. Now, what is the value of one of the electrode there?
0.
0. Now, the choice that you have there, alin yung 0? Ito or ito?
The cathode.
Okay? Because the way
Cathode.
that you want to do here is, if you're going to put the 0 here, so the other value, if you're going to rearrange there, it will give you what? Because you don't know. I mean, hindi pa rin nila alam. Pero alam nila, isa-set natin ito as 0 and this one is 0.76. So in that case, this will only be true if the value of the other one is
Negative.
a negative. Because 0 minus 0.76, that will give you positive 76. Now, some book will teach you it this way. Right? Dito gulo na yan. But what do you need to remember if it's this way? So usually, itong way na to, we look at it in terms of the reduction potential. But if you use this one, when you denote this one, so that means kung ano man yung reduction potential, you're going to reverse the sign. So ano mangyayari kapag ginawa natin ganito? So this one becomes now 0 plus 0.76. I don't know if you still got confused on that part, because that's the hardest part that I have when I'm teaching Discord at the undergrad here. But before we go on that, kailangan nyo makita yung table eh. Okay? So this is the reaction that you have, and if you're going to look at it, so this is the half reaction, and the other one would have now, if you're going to do it on the other, we could say N of the copper. How do you get the reduction potential of the copper? So it gives you what? 0.34. But in this case, if you're going to look at this, this is E cell. minus E cathode minus E anode. So here you could say, okay, that's 0.34, pero yung zero mo ay yung anode. So that means the cell potential that you have for your cathode is
34.
so 0.34 plus 0, that will give you 0.34. And that's how they construct this table. Now, to avoid confusion, what I always tell my students, you identify which is the anode, you identify which is the cathode, and use their value as is. E cell is equals to E cathode minus E anode. Kasi pag inintroduce mo pa yung ganito, wala na, kagulo na. And they will tell you, Professor, I don't know, I'm confused. I don't know if you get the same reaction there. But how useful is this table? So usually, the more positive reduction potential, that's the one that will undergo reduction, and the less one, the less value will be the one that undergo oxidation. Okay, the more positive, the greater the tendency for the substance to be reduced. The half cells are reversible. But if you reverse it, usually oxidation na siya. Okay? And the sign of the cell potential changes when the reaction is reversed. And changing the stoichiometric coefficient of a half cell reaction does not change the value of electrons. So this is an internal property. That's one of the biggest mistakes that they also have. Okay? So everyone understand how to use this. Tama ba yung pagtuturo nyo? So the other thing that I have here, hindi na tayo, I think, magsosolve, because I want to go to this, what we call the Nernst equation. So that's the simplest we could say. All you need to do is find what is the anode, what is the cathode. Okay, and you say magnesium, silver. So if you're going to look at there, so magnesium is this one. Oops. And then silver is this one. So if it's a typical galvanic cell, it's just 0.80 minus 2.37. Now, in what way is this table useful? If I want to construct a battery that will give me the largest potential, what should that battery is made up of? And I think that's the reason why it's being used in our device. Usually you want to choose the combination that has the highest here and the lowest here, and they will give you the biggest difference. That's why you have what? Lithium with fluoride. That's the lithium battery, because they will give you the highest potential. 2.87 minus 3.05. That's another usefulness that you can have out of this, what we call table. Okay. So I don't know if you know it. That's why I told you, I tried to introduce you some concept on how to teach this, what we call electrochemistry, because I think this is one of the hardest part in Gen Chem and also in analytical. So that's the experience that I have. So I just try to share to you the technique that I use. And then, knowing the cell potential, it can tell you if your reaction will be spontaneous. So usually spontaneous reaction, ano yung sign ng cell potential nyo?
Positive.
It's usually a positive sign, right? The delta, the E cell. But in terms of the delta G, what is delta G? Delta G is the free energy, right? For a reaction to be spontaneous, your free energy should be negative. Okay, so a combination of a positive E cell will give you a negative delta G. Okay, Usually, the way I teach, usually, may Gen Chem 2 ba sa atin? Are you familiar with equilibrium? Tinuturo pa ba yun sa Gen Chem level? Because our Gen Chem 2 curriculum here in the US, it's the equilibrium. And I always tell my students, okay, anong number sa atin yun? Yung ba yun 19? Or I think 18, right? Oo, 18 ata yun, yeah. Parang naalala ko na. Okay, I always tell them, Gen Chem 2 is all about K. And you as students needs to know where you place the O. So either you're OK or KO. So it's your role for the whole semester to find the O, if it's before K or after K. Okay? Because we talk about equilibrium at the beginning, that's the liquid, solid liquid phase. So we're talking about vapor pressure there. And then in the solution, we talk about the equilibrium between the dissolution and recrystallization. And then chapter 13, we talk about kinetics, which is small k. And then we go to chapter 14, which is the big K. And then after that, ayan na, nagsimula sa KC, KP, and then after that, acid-base KA, KB, KW, and then you have what? KSP, KF. That's why I'm telling my students, this course is all about K. And for you to pass the course or understand the course, you have to know your role as an O. Okay? Because there's a relationship of K also here. So if you have a delta G that is negative, what is the K value? Usually more than 1. Because the forward reaction is the one that is favored. Okay, so if you're going to combine all of them, the one that you have here, the one that you have here, and this is what you get. Usually number. So either this one or this one. And if you're going to combine the 3 of them, so this is the relationship that they have. Nasaan na yung ano ko? Nawala. And to summarize the relationship, so usually gives free energy. If it's negative, it's spontaneous. Your cell potential is positive. Your K value is more than 1. If your delta G is positive, cell potential is negative, and the K is less than 1. The backward reaction is the one that is favored. Now, how do we introduce the Nernst equation here? So if you're going to look at what we have earlier, so yung Nernst equation natin, usually, that's the notes ko. You just have the delta G. And then this one plus RTL and Q, just following what we have here. This one. So one you have here and one you have here. So what's the difference between the two? This is always what? Standard condition. So we're going to replace it with the what we call negative NFE. Am I right? And this will become what? RT LNQ. So how do we simplify all of them? We divide all of them with negative NF. And this now become E, standard E, or E standard condition plus RT, or there's a negative there, so this will become negative NF LNQ. So why the Q here? Because you have a concentration that may differ. And any change in the concentration will lead a change in a cell potential. So this is where you can have a non-spontaneous battery becoming spontaneous by just changing the concentration. And this is your Walter Nernst equation. Okay? So this is not new to you. So I think I just, we can just solve maybe one problem here. So if we follow this one, predict whether the following reaction would proceed spontaneously at 298 Kelvin. So you have a cobalt reacting with Fe2 plus, producing cobalt 2 plus and Fe. Okay. So given that cobalt is 0.15 and Fe is 2 plus, so you can get the cell potential there of cobalt 2 plus to cobalt, cell potential of Fe2 plus to Fe. And usually this is what? Negative 0.44 volts, and this is equals to negative 0.28. And based on this reaction, which is the cathode, which is the anode. So in this condition, you are the one to decide which one is the cathode and which one is the anode based on the given reaction. So what do you think is the cathode here? So if you're going to look at this, your cobalt from cobalt 2 to cobalt 2 plus, so most likely that is your anode. So you put here the negative 0.28. And this one will have the negative 0.44. And what do you have at a standard condition? Is it 0.16 negative? So what can you say? Is it spontaneous or non-spontaneous? So this is non-spontaneous. Now, we're not done yet, because what happened if we change the concentration? So we have E cell equals to the standard E cell, and then minus, we could say simplify the 0.0257, and what we put there is just the N and the ln cube. Okay, so the one that we have initially, this one, if you simplify this, that will give you this value. So we have the E cell, which is negative 0.16 minus 0.0257. And how many electrons involved? So there's a +2 on both of them. So that's 2. And then the LNQ here. So this is the product over the reactant. So 0.15 over, we could say 0.68. So will it be lower or higher than 0.16? Just to cut the suspense, this is what we have. Is 11 ano na, 11 na. Okay. So those are the things. Okay. So I don't know if you discuss it in your 18, but if you teach the lab, most likely hindi. It's the one that have the lecture part. Okay. So this is another example, but we don't have time. So you can also have what we call a concentration cell. So this is made up of the same material. And the only one that is different is the concentration of each of the solution. Okay. So the example that I have there, this is the zinc. So if you're going to look at this one, what will happen there? Zinc S producing zinc 2 plus. That's 0.1, and then zinc 2 plus, that's 1, producing zinc. And if you have here, this is equals to what? They cancel out, so you end up with this. So what happened if you have the Nernst equation? What's the value of the standard E cell? So this one is equals to 0 because they're made up of the same metal. Okay, so all you need to do now is put the value that they have here. So that's 2, and then L and Q. So what do you have there? So this is, if we're going to look at it, 0.1 over 1. And out of nowhere, you're going to get a potential. So if you just have the same amount of, not same amount, same material, same metal, but different concentration. So you will get around 0.2 something or 0.02 in that thing. So that's a concentration cell. So they just have different concentration. Okay. And you know this battery. So I think this is the, I don't know. Ever ready pa ba dyan? So usually this is a Duracell. So if you're going to look at the redox reaction that happens, so this is how it looks like. And then this is a mercury battery. They don't use it anymore because of this one. And then if you have a car, so this is the battery that you have. And as you could see, it's just lead on both sides. So pag namatay, all you need to do is charge them para magkarga uli. And if you have the lithium battery, so this is how the reaction looks like. And if you have a fuel cell, so a fuel cell, usually you have a hydrogen there and an oxygen. Okay, so if you're going to look at the reaction, that's the one that produces water. That's why if somebody told me that he had a device that used water to produce energy, I always be skeptics. Okay. And if ever you're able to invent like that, I think the first investment that you're going to do is security. Why? Because if you're able to do that, you're going to kill the economy of several countries. Overnight, yung dependent sa oil for their economy, they will collapse. And you're going to have a pretty high target behind your back. Okay, because of your what we call the invention. The same thing if you say, hey, I was able to find a cure for diabetes. Okay. They said there's no 100% solution, especially if it's a big industry overnight. But you know, sometimes changes happen. Electrochemistry made a big difference. Before here in New York, there are people who work yung tagasindi ng ilaw every afternoon. Tapos sa umaga papatayin yung ilaw, yung sa mga lamppost. Okay? Humphrey Davy even invented the light that the miners use, the safety one. But with the advent of electricity, nag-phase out na yun. Wala nang taga-sindi at taga-patay ng ilaw. Okay? So that's, we could say, progress that's happening. There's always what we call changes. Now, another, we could say, product of electrochemistry or redox reaction is the deterioration of the metal. That's why if you can find something that can make metal last forever, you can get rich. Because metal will always what? Oxidize. Why? Because we have oxygen around us. So if you're going to look what's happening here, so this is your Fe deteriorating to produce Fe2 plus, and then oxidizing further to produce Fe3 plus. And what's the culprit? This one and the acidic condition. The classic example that I usually hear in my students is the Statue of Liberty. I ask them, what's the metal made up of that made up the Statue of Liberty? They always said copper. So what's the color of copper? They would always say brown. So why is it green? The Statue of Liberty. Doon, di na nila alam. It becomes green because copper oxidized to form copper oxide, and usually it's the green color. Okay? And corrosion, we could say, if you find a way to prevent them, that's good. So the way that they do is like a sacrificial lamp. Although the example that they have here, magnesium forming iron, I think I can use the example that we have in the Philippines. Alam niyo GI? In a chemistry way. Anong GI? Alam niyo yan? Have you heard galvanized iron? Sorry na, hindi maganda yung pronunciation ko sa iron. Since junior faculty, I have a hard time pronouncing. I just call it Fe. You know galvanized iron? Anyone? Hindi nyo narinig yan? Ha? Yan, yun sa bubong. So usually, the roofing that we have there is made up of just what? Iron. So kapag sinabing galvanized iron, anong metal ang ina-add? Anyone? Aluminum ba? Ang mahal naman. Ginagamit mo yun sa sa kaldero. You never heard this? Well, as a student, usually I always tell my student, especially the Filipino one, usually they mix it with zinc. And if you're going to look at the reduction potential between iron and zinc, yung zinc mas mababa. So ibig sabihin, pag nag-oxidize siya, sino unang ma-oxidize? Yung zinc o yung iron? Okay? So if you're going to look at the reduction potential, kung ayaw nyo maniwala, balik tayo doon. Layo. O yun. So you have here the Fe. Where's that? All I know, the zinc is around the 0.76. Ito yung zinc, right? So yung Fe, sana yung Fe? We have an Fe3 plus here, pero hindi yan. Dapat yung metal. We have an Fe2 plus. So this one. So it's 0.44. So if you're going to put them in front of the oxygen, which one will oxidize? Usually the one that has the lower reduction potential. And the good thing about it, when it oxidizes, form the zinc 2 plus. And in this case, the zinc oxide. And they provide additional layering doon sa Fe. That's why if you have, I think, a galvanized iron, that's 20% longer compared doon sa ordinary iron. Yun yung chemistry behind doon. I'm surprised you don't know about that. Because you as a teacher, you should use the materials that you have around you. Yan yung isang classic example ko when I'm still there. Okay? So I hope you learned something that you can use when you teach. And then we have the electrolysis. So electrolysis, as I told you, you use energy to make the reaction proceed. So here, that's one way to get the liquid sodium and the chloride gas from NaCl. So ang ano doon, mag-a-apply ka ng energy. Okay? And classic example dito, of course, yung hydrolysis ng water. Okay? So you have here water form oxygen and the acidic part forming an H2 like this one. Ang magandang example na ginagamit namin dito, lalagyan namin ng Ki solution, tapos lagyan namin ng carbon rod, tapos ilagay namin sa battery. So if you have a Ki solution, okay, ang ma-observe namin, magpo-form ng iodine tsaka H2. So one will form bubbles and the other one will form some brown liquid. And we ask the students which is the iodine and which is the hydrogen. Okay. So that's the thing that we do. So electrolysis, if you're doing the problem, so you use here the Faraday constant as we have here, but I'm not going to do it. Okay, but I'm just trying to review the electrochemistry that you have as you should learn in the Gen Chem level before we go up. And I hope you learn something. So at least meron pa tayong 7 minutes for some open session. So question. Yes, Carmel.
Sir, I have 3 questions po. Yung first question related sa topic, like, how is gel battery different from other batteries and why is it sometimes preferred over the others? And then yung
Gel?
Gel, yeah po, gel type. And
Gel
then,
type?
opo sir, tas yung dalawa ko pong question, yung isa po ay, may grace period po ba tayo? Like yung 10 before the end of time.
We'll try to. I'll try to. Okay? Yeah. I'll try to end up before that time.
Okay. Tapos yung last question ko po ay, magpo-provide po ba kayo ng slides?
Now, the slides is available.
Thank you po.
So the gel type, I have not encountered anything, but sometimes, you know, the condition that they have will have an effect because usually it has something to do with the transfer of the electrons. So siguro if it's a gel type, mas ano yung transfer ng electron, mas efficient. So mas maraming energy yung na-generate. I think just that's just me. Okay, looking it from a practical way. Because ano ba yung nagko-cause, ano yung nagpo-produce ng energy? Why do we have electricity in the first place? It's just the transfer of electrons. And remember, usually if you have a salt, they don't conduct in solid form. They only conduct in what? Kapag dinisolve mo sila sa solution. Right? So I think I go with that aspect kung bakit yung gel like mas we could say efficient compared to the solid one. Okay? Question. So we're going to start with electroanalytical. We will try to look at this as the the history, and you see how some of them got a Nobel Prize winner. Award for doing this thing. I think the one in polarography got an award because I find an article written by my former mentor in Austria. Okay. And then we go with the basics. So I don't know if you're familiar with the migration, the convection thing, yung mass transfer. Okay. So how are they differ? And then I don't know if you know what's the Faraday and non-Faraday condition or situation. Okay, so those are the stuff that we really have. Now the thing for now is I think this is the calculation that we do. I don't want to do like derive as you could see in one of the books. Okay, so yun lang yun. So question, meron na kayo napiling ano? Meron na kayo napiling topic if ever? Or you know how to use maybe an AI to aid you? Sa tanong. So in 2 weeks, I might ask you to attend, although 8:30 yung start niya. That's where I came from earlier. So it is by paase. I don't know. Unfortunately or fortunately for me, I will be the speaker in 2 weeks. It's just about educational innovation. So Dr. Gisela Sanchez invited me. So maybe you can learn a thing about there. So I'm not sure if I still have the energy to meet you after that. Because what will happen is I found some videos about electrochemistry. So I may just connect you with the links on those videos. Okay. To what we call make up for the time that I'm not going to be able to meet you. But I'll try to what we could see. Because as of now, they're still there. Because I just messaged Dr. Concepcion, I have to leave because I have a class at 10. That's why I was late. So tanong, sorry kung nag-overtime ako. May tanong? Do you have class before here? I think si Judy, you have a 7 to 10 class. How about the others?
Sir, ako po LA ng 8:30 to 10.
Ano LA? 8:30
Lecture
to 10.
assistant po.
Ah, nire-record kayo umupo. Ganun din.
Yes po.
Oh, ako, nag-lecture ako noon eh. Yung lecturer ko, nandiyan pa din eh. But it was helpful. That's all I could say. Sino pa yung before, may class before? 8:30 to 10? Wow. So may lecture na 7 to 8:30? Oh, shoot.
Yes, sir.
No, our Chem 137 during that time is Tuesday, Thursday, 7 to 8:30. And then, pag minalas ka, yung 180 namin is Monday, Wednesday, Friday at 7 to 8. At pag kinuha mo yun in one sem, Monday to Friday, you have a class at 7 o'clock. Because the one teaching during that time is just one person who happens to be the CAS Dean, Dr. Baril, or we call Dr. Bang Bang. So yun lang yung time na pwede siya magturo. So iniiwasan namin na kunin siya at the same 137 and 180. Usually you take them at the same time. Kasi may klase ka ng alas 7 every day. So we just take one semester and then the next semester the other one. Okay. So tanong, it's already 11:30. So if you don't have question, thank you very much. Yung iba kung gusto pang magtanong, you can stay, but I'm going to turn off the recording.